Hello ladies and gentlemen, and welcome back to another screencast by your Earth Science teacher, Mr. Stano. Today we're going to move on to volcanoes. Here we just have an explosion of an underwater volcano back in May of 2000. And we can see that there's all this ash rose up around 200 feet. So pretty high, huge amount of force around it. What's generating all this force? We have a sinking volcano right here, that atoll that we were talking about a little bit on the previous screencast, as these basically volcanoes break down over time and the material settles on the outside. We have the Cascade Volcanoes we're going to talk about here in the United States. So over in this region, there is something that's happening. We know that this is a convergence zone. We can look at our reference table. So one plate, we have the Juan de Fuca plate that is subducting underneath our North American plate. And as it subducts underneath, we have friction building up, materials get hot, and magma is going to rise to the surface. All along over here, our Cascade mountain range. The Cascade volcanoes. And once again, taking a look, that Juan de Fuca plate right around here, moving this way, North American plates moving that way. So we have a number of active volcanoes that are within this region. This is just looking at the number of eruptions over the past 4,000 years, and you can see Mount St Helens extremely active, coming all the way up through 200 years ago. Baker, Glacier Park, Mount Rainier. Okay, all these areas right here are pretty active volcanoes. Here's Mount Rainier in Washington. Pretty cool. Okay, and Mount St. Helens, which in back of May of 1980 actually erupted. Okay, this is 2 years after the eruption, and you can see, we'll go back. This is how it looks. And then notice, blown apart the whole side of the mountain. This is just looking at time lapse of it. So at 8:30, 8:32, and then finally here, that's the actual eruption. So you can see in a very short period of time what can happen to a landscape. This is looking at the ash flow. So our predominant winds moving west to east across the United States. So as the ash rises up, notice how it moves over. Okay, and what we end up getting from the blast is something like a singed forest. All these trees knocked down. We can actually see them a little bit here. Look at the size of these trees. So these are people right here. Trees knocked down. All of them from the blast. Okay, this is just looking at a tree trunk. Same thing. From that blast, this pyroclastic surge knocking these trees down. We'll talk more about that in class. A number of other things. Mud flows, unstable ground. And what we end up getting is this huge amount of mass movement. Okay, same thing. Take a look at all this. Mass movement. We have a big change. Mud flows that form in these areas. Right here, moving up to the house. So what happened from Mount St. Helens? Basically, anything in the immediate area was gone. Animals living above ground in the blast zone had no protection. We lost a lot of them. Trees within a 15-mile radius. Here, huge, snapped in half. Those pictures that I showed you. 7,000 large game animals were dead, and then 26 lakes in the surrounding area from that ash that makes it in, or from those lahars, get damaged. 11 million fish, 57 people died. Most notably, this guy right here, David A. Johnson, volcanologist in the area, who basically he was in the region when Mount St. Helens went, and we never found him. That's it. That's the end of plate tectonics. To leave you on that sad note, I hope you enjoyed this screencast. Take care. Goodbye.